Okay, so hello everyone. The first 30 minutes from this class will be dedicated to download the Anaconda Navigator because we are going to work on Python code execution. You are going to find that on like week 7 modules, and you are going to be able to download Anaconda easily from that link provided there and how to answer the guide. After that, so I'm going to go quickly through the k-means that we already seen last time, but this review is only because last time most of the students were absent. So what we seen, we were going through types of learning, and we say that we are moving from typical programming based on rules, and like algorithm that I have set of rules, and based on rules, like the computer is going to take a decision. Now, what we do is that we are going to be based on learning, which is different from rules. Because if I have a set of rules, I cannot think of anything or any possible rule out of these rules that I'm defining, okay? For learning, each time there is a new, with the experience, with the new data that's seen, I can generate new knowledge. Okay, so this is the main difference. For learning, we've seen there are different types of learning, which are mainly supervised, unsupervised, like semi-supervised, and reinforcement learning. So unsupervised is when data is there without any labels. Like this example, I have a set of shapes and I don't have information exactly what each shape corresponds to. So I have no information about the class to which this shape belongs. We see the supervised
Sorry to
learning.
interrupt. It looks like it's not showing on the Zoom screen.
Oh, sorry. Okay.
Sorry.
Let's share the content. Okay. So thank you, Zoya. So the supervised learning, we have the additional information about the labels for each shape. What does that correspond to? Okay, for example, I have rectangles, circles, and so on. Okay, so you have the class for each one. And we've seen examples or application cases for each one. Semi-supervised, we say that it's where the training data contains a little amount of data, which is labeled. I know these fruits, for example, orange and banana, and I don't know some other elements or the given label for some samples, okay? So this is for semi-supervised. Reinforcement learning has a different like context where given my data, I'm going to learn based on a reward function. It could be like positive value or penalty, and based on that, I'm going to the algorithm, is going to decide about which action to take and at the end to perform some task. So these are the types of learning, and during this semester, we will see 3 main types of algorithms. Not learning is 3 types. Also algorithms, we have mainly 3 types. The generative methods, we've seen last time the k-means. Discriminative methods like KNN, SVM, and so on, and the ensemble methods like decision trees and so on. So what we will see now is the k-means. Quickly, k-means is mainly dedicated for segmentation. And when we talk about segmentation, like the example of the first class we said of machine learning, we were discussing new terms and concepts when we were brainstorming. So at the end, what we did is that we are coming up with the ideas of clusters, how these examples are at the end. We were able to form groups, and the groups are formed, for example, those who are having like students who are suggesting keywords related to data, they are in the cluster of data. Keywords in the context of models, they are with the models. So we are forming groups or clusters. And here, as I was discussing last time, so clustering itself, we were defining it. It is the process of finding the elements that belong to groups. Within the same groups, elements must have a lot of common like characteristics, and they have different characteristics from the elements that belong to other groups. Okay, so segmentation is there in many like application domains. And we said one of the examples is given, for example, the Simpson cartoon. I was asking you to form groups. So some of the students said we can divide them to those belonging to the family, others to the employees. Other students said we can divide them to men and women, and we can divide even not only to like 2 clusters, we can divide to more clusters, okay, or groups. So this proves that segmentation is subjective, and we cannot like have a fixed rule that says it's based on this we can do classification. So it depends on the context and so on. So a cluster I was just mentioning is a group of forms that are similar and having the similarity with other elements. So here we see like a good clustering method ensures high intra-group similarity and low inter-group similarity. And in this case, for example, I can find the groups that are similar. For example, the first two, which are the similarity or the common point that are, these are image data. Others, for example, are web pages, or for the other case, it's a table, okay? So it depends. And next, we were moving to modeling things. So when we want to model, we use our tool, which is mathematics. So given a shape, I'm going to call that y. And this y is going to have a hidden state. This hidden state could be like represented with a feature vector. The feature vector, called also the attribute vector or the observation vector. It depends on the context that people from different fields given the same things, many like names. At the end is the vector describing the characteristics of the shape y with the different attributes that are x1 to xn. So for this one, if we are going to store it in a data set where there is no information about the class to which this shape belongs, so it's unlabeled data. If we have the additional information y, then it is labeled data, okay? Next, what we say that cluster could be represented with one or more centroids, and the centroid is the representative of the cluster, which means I'm going to take one element, I'm going to consider that as a reference, okay? So it's a prototype or a reference shape, and this will allow me to divide my space, whether in the case of a 2D space, I am going to have a linear decision like surface, which is going to allow me to divide my space into 2 parts, so that if a new sample is coming, for example, if it is in this side, so it's in the left side, for example, of the line, I'm going to consider that belonging to the red cluster, I would say. If in the other side, I'm going to consider that it belongs to the blue cluster, okay? So this will allow me to divide my space. And when we divide, we do not only use linear functions, we can use like non-linear functions. And in this case, this is an example where one of the clusters, here we have 2 clusters, you see, but one of them is represented with more than one centroid, which is still possible, okay? So we said that how to do this, we were detailing last time, that each time we are going to check the distance between these, and I'm going to like have the median for this and keep doing that, okay? So next here, for example, is a case where I have 5 clusters and each one is represented only with one centroid. So what next we see is that for a shape, we can have different names for attributes, also called like primitive descriptors, variable features, or whatever. For the shapes, it's data, pattern, example, sample, or whatever as well. So in this space, each attribute belongs to a subset of the forms, and this set of subsets together, they form the whole like set of forms, okay? So for omega now, it could be whether quantitative or qualitative attributes. When we're discussing the titles or subtitle types, of quantitative variables, we said we have the names. A name, for example, the weather values, they are not numerical values, they are not quantitative values, they are qualitative values, and these qualitative values are names, okay? So the nominal attribute in this case for the weather, it is sunny, rainy, snowy, and so on. So how do you know some nominal attributes? The rule says that between nominal attributes, there is no relationship of order. One says, for what I'm going to use this, for example, if there is no relationship of order? So if there is no relationship of order between the nominal values, there is a more important relationship, which is if two values are equal or not, okay? So which is useful or very useful for the test cases in algorithmic like example. For example, if I have the weather is equal to rainy, then the match is equal to no. So here I did a test of equality, okay? The other type of qualitative attributes is the ordinal one, when there is a relationship of order between them, which means if I have things like hot, cold, moderated, I know that hot is superior than moderated, which is superior than cold, okay? And in this case, I can say if temperature is superior, strictly superior than cold, strictly superior than cold means that it's hot or moderated, okay? Then there would be a match. So match is equal to true, okay? This is an example. So last time also, Ayub was saying that for an image, and you can see these two images, is a set of pixels, okay? So in order to compare two images, and I'm not going to compare, if I'm going to mainly set each image in a cluster or set them together in a cluster. This is going to be based a comparison. The comparison is made given a distance measure, and we said last time how to compare two images. Some like propositions were saying to compare pixel by pixel. So we were saying, so in this case, we will find these two belonging to the same class and these two belonging to the same class, which could only make us careful which similarity metric to use. Because when we talk about metrics, there is not only the typical Euclidean distance that everyone knows, which is a particular case of the Minkowski distance given by the following general formula, I would say. It's a particular case when this p is equal to 1. So when p is equal to 1, we have this formula of the Euclidean distance. Equal to 2 is the Euclidean distance, which is the square 1 divided by p. In case the p is equal to 1, it's the Manhattan distance. We were already discussing this in search problems. And if p now is up to infinity, so we have the max distance, which is having this formula. We were detailing this last time. But what I can explain for you, we said that there is a set of distances, and it depends on the context which distance to use. So if I'm going to ask you now to give me the set of points with the distance equal to 1 from the origin, means you give me all points with the distance equal to 1. First question, you must ask me which distance. So I will say all the points that are having an Euclidean distance is equal to 1 from the origin. How you can imagine the whole thing? Which are the points that are given the distance 1 to the origin?
1, 0, 0.
This is one point which is distance 1, Euclidean distance 1. This is Euclidean distance 1. This is Euclidean distance 1. And this is Euclidean distance 1. Also this, if it's 1. So all elements that belong to the circle, like, is it clear? So all the elements belonging to the circle with diameter 2. Okay? So here is the visualization of the Euclidean distance. Okay? Now, I was just saying that other distances are different. It is clear in the graph. If I ask about the Manhattan distance, it is this. Okay? And if I want to visualize the max distance, so it is this, which says that each distance really have a different interpretation from the other one. Okay? Which makes it a very important step to choose your measure. Okay? So next, we were discussing the nominal attributes. And here there is a rule to compute the similarity between two like feature vectors, x and y. We were detailing or going through these like possibilities from the conversion matrix, sample matching coefficient, and the Jaccard coefficient. So then we move to the k-means, which is a first-step algorithm. The first step is to initialize or choose how many centroids, such that, for example, okay, how many centroids, how many clusters, how many objects, how many clusters. So the decision is called k-means. So the first decision is about k, which is the number of clusters that are the number of objects that are forming the number of clusters. Okay. Once it's done, let's suppose we have 2 or we have 3. I'm going to reassign each object O to the cluster Ci with the center Mi, such as the distance between like the object O and the center Mi is minimized, because the more you are near to the centroid, then the more you belong to that given cluster that centroid is representing. And then we calculate this distance Mi, center, for each cluster, and go back to this step, keep repeating until convergence. How to make it clear? There was an illustration. So deciding about k, here we said, let's say like k is 3. And we said one of the inconvenience of this algorithm is the choice of k. So we will discuss this later. Next, we are going to set them for a given position. Let's say the first one here, the second one here, the third one here. And the third step is to assign each individual to the nearest centroid. So we are checking the distance, and if it's more near to the green one, it's assigned to the green one. More near to the blue one, then assigned to the blue one, and so on. Now what we will do, we are going to recalculate the position of the centroids, because the first position is random, and then it must be really, let's say, having the optimal position within the cluster. Okay. Now what we will do, so for example, this one, we figure out there are 3 elements that are in the left side, one only in the right side. So the cluster must be more near to the most elements, okay? And then for the green one, same, and for the blue one, same. So we are doing this, and we keep doing this until there is no more like moves. It's going to be stable, and we say that it's converging, okay? So this is the k-means algorithm in few steps. The stopping criteria is like when to stop. Convergence, as we were mentioning, which is the main criteria, when there is no more like changes in the assignment of the shapes, no more changes in the positions of the centroids, and also there is a measure of the error, which is the performance measure, I'm going to say, which is the squared errors given by the CSC function. Also, we were discussing the advantages, disadvantages of this algorithm. The advantage is that it's easy to implement and it has a low time consumption. Also, the disadvantages are like the case of handling outliers, and we were discussing outliers are the elements that are extremely far, for example. And these elements, if they are extremely far, they are going, if you are going to include them in computing the mean, also they are going to distort your like means. And there is a need for numerical attributes to calculate. We need to manipulate numerical values. And if even we are introducing formulas to move from qualitative to quantitative, it's still a problem, okay? But the main problem in my point of view is the empirical choice of the number of groups k. And here we said that there is a set of methods. There is not only one method. And so this is why I generally don't include the method or a particular method, so I teach you that, because there is a set of methods and the choice depends on, because if, for example, one of the methods is the elbow method, for example, which is for me the best one, okay? In general, I use this one. I cannot say that the gap static is not a good one, or cross-validation is not a good option, or other like methods are not good, okay? So this is for the k-means, and we are going through this quickly, otherwise last time it was really detailed. Now let's move to the implementation. Now supposing that everyone is having, what we say, the Python or the Anaconda in their laptops, everyone is downloading the code. We are going to explore together. Okay, I'll stop sharing from this laptop to share from mine. Oh, Jeremy is coming exactly on the right time.
Yeah.
Because last time, this is just we are covering what we seen last time.
All right.
And now we are starting to see new things, cover new things.
I think you waited for me.
Okay, welcome. Okay, so let me share my screen. Okay. I wish there is no problems. Okay, so you can see my screen. Okay, at least there. Okay, so for this one, I'm stopping sharing, so it will not be shown in the recording. For this one, so what I have here, I'm downloading cars txt, which is a file having information about cars. And I'm not the expert of cars, as you know. So there is, at the end, a set of metrics. Based on that, you can decide, like, maybe if this car is good in this context or not. One of them is this MPG, displacements, horsepower, weight, acceleration, origin, and so on. Okay. Next, so when you see your data, okay, your first interest is the extension. So it's txt file, which means it's text. So this is going to be very important for the step of uploading your data into your notebook or project. The next step, which is also important, is to go through your notebook. So here I'm going to suggest you something. Always, if you are downloading some file, do not straight start working on that, okay? So always try to duplicate that, create a copy, let's say, and work on that copy. Because if you try to open the original one, it's going to give you the example of this like notebook already executed. So you can see what is a notebook composed from. So what we can see here is a set of cells, and these cells could be whether containing some code or the results of the execution of a given code. So if you are going to upload a given notebook, so you are supposed to find the previous like prints or plots of previous results. What you are going to do, you are going to like create a copy, so you still compare what results you are getting with the previous results, because at some points you may get some errors, and these errors are only due to some versions, some like things related to the environment or installation within your laptop. Okay, another way or option which is also possible, I was saying, it is the execution using Google Colab, which is not a bad option, but it cannot be the option that is used forever. So it's still a good option. So now what we will do, I have in this notebook a set of like cells, and we are going to execute them together. So the first one is just about importing things. So I'm going to remove the commands each time, or let me download it. I'm already downloading, no worries. So for you, I think it's already commented the code when you are downloading, right?
I know it was when I downloaded it into Colab.
Whatever, if you try just to check, I'm going to check from this laptop. Whatever the code I was uploading in modules, it is okay. You can see from here. It is not converted. Okay, no worries. But in general, what I do is that I provide you with code where if you keep removing the commands like here and just execute things. Okay, so what we will do now is that we are going to execute. If any commands are there, then no worries. So first thing we are going to import numpy, pandas, matplotlib, pyplot. So the import is that we are bringing this library, and here we are bringing 3 libraries. The first one is numpy, pandas. It's used for data analysis, for plotting, for like uploading data, for things like this. And when we import things, we can whether import it like as it is. I say import NumPy, and then if I am going to use this library, I call it NumPy as it is, or I say as NP. So I'm going to give an abbreviation, and whenever later I'm going to use this like library, I'm not going to call with the full name NumPy, because sometimes, as you can see here, we have long names. So I'm just going to call it with its abbreviation. Here, the matplotlib pyplot is the library for plotting things, for visual representation of like or given graphs or plots of your data. So the first thing is to explore our data. And here, what we will do, given a country, for example, the context for this, for a given country, they are importing cars from 3 different countries, which are USA, Japan, and another country, Europe. You are right. So the idea is that we are going, based on the characteristics, I think you are guessing this country, right? Okay. So based on the characteristics or features for each of these like cars, we are going to decide if it's good or not for these roads. So the roads of this given country. So what to do now is, first thing, we need to import our data. To import this data, we are going to use pandas as PD. As I said, this is just a replication of this line, okay? So to import data here, we are using this one. So what to do is, from PD, which is pandas, we are going to use the function read table, because the txt table now is going to be read as a table. And we are going to print header here, and also print the index of each column, okay? So how to like check things or search for things? The first thing, in general, we search if we are going to use a new function. Now, in this time, we're searching from ChatGPT. But what I always recommend is to search from like trusted sources, like, for example, the documentation. For example, here, you write whatever you want to check, and the official documentation. So in the official documentation, you are going to find this pandas or PD, as we are mentioning, read table function is having the following like parameters. And by the way, there is 2 ways to call this function. Whether, for sure, we are not going to give the whole parameters. So whether you are going to give which parameter name like equal to what you are going to give as instance, or just to respect the order. So here, for example, the first one is the file name. So this is why we are not mentioning the name of the parameter, because it's the first one in the order. Next, here, at a given point, there is the header. So I cannot put it the second one without mentioning header equal to. So this is why I'm mentioning or specifying the name of this parameter, okay? You don't need to give the whole list. Whenever you need something, don't forget to mention the name, especially that there are parameters coming first, okay? If it's the first one, second one is respecting the order, only in that case, you can remove the like original names of these parameters while calling the function. So here we are calling the read table with 3 parameters, cars txt, header 0, and index call is 0. The remaining of, as you can see here, so you do not have only one, you have a long set of parameters. So those you are not calling, they are going to take the default value. And you can see here, for example, each one is initialized to have default value, okay? So here we are calling with whatever value that we need and we know, and it's like this. So if we run this cell, what we are going to have is we are going to have the data set. So how to run things? You just click on this, okay? Run this cell, you see? You see it, right? The triangle on the top.
Yep.
So you just click on that and it's running, okay? So it will give you no errors. This is the good thing. Next, what you have is that you have the 5 first samples of this data set. If you go back to your text, you are going to find exactly that. See? And what you will see, like the also headers. These are the headers. Sometimes you can do it and you do not like give the value 0 to header. You give 1, for example, then it's not going to be there. Next, now you have a whole dataset file which is there. You need to understand your data. So you need to know the basic information about this data. So you need a detailed description for that. This is why I always suggest using the describe function. Okay, so your data is uploaded as data. You can see here it's called data. So data.describe is going to give you a description of your data. This description is going to have the count, means the number for each one, the mean value, standard deviation, the mean, like if it's belonging 25%, 50%, 75%, and the maximum value. So like this you understand, because for this example, since it's the first example we are treating, it's very simple. There is no problems with data, there is no duplicated data, there is no missing values. However, when it comes to dealing with data, you usually have problems. So sometimes this max value means something. If you are having image data, for example, and you find the max value is like 1K, you know that the pixel value cannot cross 255. So there must be a problem with your data. This can give you an idea if everything is okay or not. So we are okay. We are going next to understand what data type is there. And data type is very important because some libraries like do work with particular data types. Like for example, for pandas, it really handles very well data frames. And here, data type is a data frame, and we are good. Next, we need to understand each time the shape for our data. And the shape is going to give you kind of dimensions, okay? So you understand. So data.shape is going to give you 392.6, which is how many rows, and for each one, how many rows and columns for your table, okay? Next, now, what columns name you have, just to confirm, this could be done data columns. So you have in these MPG, displacements, horsepower, weight, acceleration, origin, and so on. The data types now, within each column, we are going to have values. And so we need to check this. So for each column, there could be data type, which is different from the data type that exists in the other one. Like if we take, for example, this displacement here is an integer, 64. However, for the origin here, it's an object. So like this, we are understanding the data types and so on. Next, if you want to read more about descriptive statistics, I'm keeping one like useful link for you. Otherwise, if you want to understand our data now, we can plot things thanks to the PLT like library, which is matplotlib pyplot. So each time here I'm mentioning which libraries we are using. And now what we did is we are plotting things given this representation. Anyone knows what type of plot is this? What is the name of this plot you can see?
It's called like a box and whisker plot or something weird.
Yeah, so this type is a box plot, okay? And when it comes to box plots, how to use that? First thing, I'm going to use the SNS library, which contains the box plot function. And I'm going to give it my data. ilog, this will allow me to locate, like given the index of my elements. I'm not going to take the whole data set. I'm going only to plot those going for like all rows, or I'm going from 0 to 5. Okay, so I'm just like here defining from where to where. Okay, it's not the whole thing. So given this box plot now, I have something like this. So in the x-axis, I have my, it's supposed to be these my columns, and here different values. So in general, the box plot, I'm keeping here an explanation about how is it, but shortly, it's a representation given like it's going to divide your like data into interquartiles range, which is the IQR. And this ranges between the first quartile, the second, and the third. So we have 3 quartiles. And first, for example, contains middle one, 50%. It's always in the middle. Otherwise, you are in the first or the third one, sorry. And then you have the line inside the box, as you can see here, or sometimes it's not even visible. So this is the median line given that data representation. And also you can see like at the end, for example, some outliers could be there or points. It can reflect something. So from this example, what we can see, so that for the weight we have the data here, it's more what you can see here, if you compare the acceleration or even the acceleration to the weight or the MPG to the weight.
It's a bigger range.
This is bigger, you are right. And even the median here is showing more. So we can see that the hair is the weight is the most spread out variable in the data set because it's ranging between like different values, okay? There are different multiple ways to represent things. Here, for example, we can use the scatter matrix. And for doing this, we use within pandas, we use plotting. And so scatter matrix, we are going to feed it our data and decide about the figure size, which is going to be 9 by 9. So here what we will have, it's a representation again for our data. So what you can see in this box plot is exactly what you can see in this plot, is exactly what you can see in the rest of the plots. So it's only different representations. It's only we are using different tools. So this tool is the scatter matrix, which is going to give you a matrix. Size is fixed here by 9,9. And so you have a 9 by 9 matrix, which is having on the diagonals here the histogram representing the distribution for this data. And each time, for example, you have MPGS function at acceleration, weight, displacement. And whenever it comes to that element, you will find on the diagonal, like for example here, horsepower is there where you find the histogram. This representation is different from the next one, which is the what we say. We are using here the seaborn for representing the pair plot. And for the pair plot, you see on the diagonal not histograms, but the distribution, okay? So this one is used to give maybe more accurate information. Things mainly you can see here, if you can keep or compare both distribution, are quite similar to what you are seeing here. However, here you can see them with, like, for example, colors is a very important feature. When you are writing a scientific paper, for example, it's very important to decide what plots that are going to make it easy for the reviewer or the reader of your paper and that are going to be more understandable. So this kind of pair plots shows the pairwise relationship between variables in a data set, which is similar to the scatter matrix, but adds the option to display the distribution of variables or the diagonal, making it powerful tool to exploratory data analysis. Okay, next now we have the famous, where is it? Oh, it's a copy. Let me execute from the start. The famous confusion matrix. Why is it? No, it's not. Ah, okay. Excuse me for 1 second. Is it matrix? Just anyone else is having this error?
could not convert string to float.
Yeah, the Japanese one. Because
Yeah,
it only deals with the numerical values. We're just fixing this. Where is the code? 1 second. You can fix this as well. Okay.
Is it gonna be in our text file or?
It's a text variable. This is why we need some conversion in the middle. They was doing that. So here, because only to the version. So before it was executing fine. And then this one. Just 1 second. 1 second. Start this one. Just select it. Are you able to fix?
I'm not sure how to edit it.
Hmm?
Not sure how to edit it. Are we editing the value in the text file?
You can do that, but I don't know what's
I
happening.
just dropped the origin column and it worked.
Yeah, it's possible like that.
Yeah.
Okay,
I
so
want the origin column.
I'm
What
not
you
so
did?
familiar with Jupyter, so I don't really know.
Yeah.
Like,
what you did? How you did that?
I'll just bring my laptop over.
You can share. No, you can share your screen. You are not connected to the meeting.
No.
Just join. You can join. It's there in your. You don't have the link. Okay, no worries. How to do that?
if all this was happening, I would have brought in my really long HDMI cable and everything would have been fine.
Okay. With the I love, right?
Oh, no, I just did the pandas. So I made a new one
Yeah, you can come.
and then put the new one in here. So it just doesn't have the origin anymore, so it's not trying to convert it.
Okay, so drop column, which is the origin, because it's the other like elements. They are numerical values. The origin is like Europe or US,
Yeah.
or so it's not a numerical value. It's qualitative variable, and we need to drop that. Okay,
Yeah,
Right.
you can also do that.
Translate.
I don't wanna do that.
Yeah. you can do that.
It's just easier.
Okay, you did that.
No.
No.
I will create an assignment right now.
Code it.
Okay. Oh, so at the end, what is a confusion matrix? Let's come back to sharing. What is it? So what is the confusion matrix? Most of you are familiar with this. I'm going to share with you the new version of the code for sure. But for now, what is it? The confusion matrix is a matrix which is going to have the dimension. How many elements do you have? Your columns, which as the features. So here what we have is 5 features. For each, you are having 5 by 5 matrix. And here for the MPG, its number is 1. So the belonging is 100%. And here you are finding the distribution of this, for example, based on other elements or other features. So here, so what you can see is in general, you are finding 1 on the diagonal, and for the rest, you are going to find different values. So this is a confusion matrix. It could be like interpretable in different ways. So what we will do now is that we're going to execute the k-means, because until now we are only exploring our data. Until now we are only trying to visualize, given some tools. I will be sharing with you some PDF where you can find all the tools with how to do that, and I wish it would be helpful for you. So now we are going just first thing. What's wrong? Okay, so here the first thing to work with k-means is that we need to have data, which is, here we need to separate the labels from the features. So we have kind of supervised data with labels are going to be saved in data labels like variable, which is going to be different from the rest of the data. This is where we use the ilog. So to have data without labels, and in order to have the labels, I am going to take the given column where I have my labels. Okay, just a separation of data. Next, I am going to scale my data. I'm going to do some pre-processing like normalization or like transformations. It depends. So this is for the very simple examples. For more examples or for more advanced like treatments or pre-processing, you can go to applying the ACP, the PCA, sorry, the principal analysis component. It's like you are going to have or perform some pre-treatment to your data before feeding that to your model. So next, once you feed that to your model, so what will happen? It's not an error here, just a warning, so don't worry. I am going to use model k-means, as simple as this. I'm going to give it how many clusters. As you can see, this is something k that I can fix manually. And then I give a random state, whatever, and initialize for any like, and do fit, so to train my model, okay? So as simple as this for calling the k-means, and for all the rest of machine learning algorithm, you are going mainly to do the whole thing in like one line of code. So don't worry now when you are going to see the projects, there would be many algorithms, but for each of them, it's just one line of code. The whole thing is, it depends like how to read your data, how to present your data, and then next, how to interpret your results. Because now, n clusters is equal to 2 is something random that I am giving. I could put 3, I could put 5, and if I'm going to have two groups working on the same thing, clustering the same data, I'm going for sure to ask why you are putting 2 and why you are putting 3, and you need to convince me. So here I'm not using any like methods or elbow methods or anything, but in order to, let me say, fix some limitations of the k-means, I am putting the second part about hierarchical like clustering. Is a different method which is going to provide more detailed solutions than k-means when it comes to detecting the number of classes and so on. So this one I'm going to keep as an assignment because we do not have time. I want to explore this part, try to learn about it. It's like extra work for you, okay? Now let me move to the second part, which is going to be about what is going to be that project discussion, which is the most important thing for now. So now moving to the otherwise before moving, excuse me, is there any questions related to this part? Like, it's just the first steps with coding. So just it's good that we are installing Anaconda, we are executing things, we are exploring things. For now, is that clear? Nothing is hard with implementing k-means algorithm. So the k-means algorithm, just you call the k-means function and it's there. The thing is about the choice of your hyperparameters, okay? And we will see about tuning, and there are like many things to discuss. But for now, let's share. Okay. Okay, so this is not the final project, just a draft. And I'm still not sharing to the classroom. At least we have online like how many? We have 3 online, and we have like 6 in person. So there is like almost half of the students are present today. We are 20 total. Yeah. So what I am going to suggest, or what I already did, so is that I am forming groups. Yeah, we have 20 students in our class. So what I already did is that I'm forming, like creating 3 projects. So each student is supposed to choose 1 project. There are 2 projects that are similar. It's the same project I'm going to give to 2 groups, but I'm going to keep freedom for the choice of algorithms. So I'm given a set of algorithms. Each group is going to choose based on the number of the students, some algorithms. I'm sure most of them will be common, but there is some flexibility at least, okay? So projects are going to be mainly in machine learning, because this is going to be really useful when if you are going to have interviews to get a job or internship or whatever, you are going to be asked questions about like what ML projects you did or something. You can say, I am doing this or that. You can add this to your CV at the end of your semester. And there will be 1 project which is going to be a deep learning project. So for 3 projects, there will be a phase where you are going to understand things. The difference between the 2 projects, first and the last one, is for the first 2, you are going to understand your data. Okay? Because it depends on the context, and you will see. For the deep learning project, you are going to understand your research paper, because it's going to be a study of research paper. Okay? Great. Now, the 2 first ones are going to be in ML context. The last one is deep learning context, and I'm going to say advanced deep learning. Okay, so like this, we are covering AI with the 2 subfields, machine learning and deep learning. If you want to add to your CV, like deep learning part, you can go for the last project. There will be deep learning in the first one, but just classification using typical deep learning like algorithms, and you can add more algorithms and work more, and like that it will cover the whole thing. If you want to specialize in something, it would be the last project, and it's up to you to choose. So we have, group 1, group 2, group 3. I'm going to give you the flexibility to choose, okay? And at the end, I'm setting the number of students for group 1 and 2 to 7. And for group 3 is 6. So when it comes to working with groups now, it's a skill to learn. So you imagine you are the, no, I'm not going to say you are the CEO of the company, because you are going to make people out. I'm going to say you are the manager of a group within a company. So you cannot make people out. You have no option other than working with them. And when you are working with people, you can expect, like, maybe they are not available all the time. Maybe on the deadline night, they can get sick. And, uncertainty is something that we must understand if we are doing AI. So itself, to be able to manage your group, to be able to work with others is a skill. So this idea of crying and saying, oh, we are not working because X and Y were sick, I would say this is a bad group. This is the bad manager for the CEO. So the good manager, I'm not going to say you are going to do the whole thing. No, I'm not encouraging others to not work, because at the end, for the validation, there will be like marks given for the whole work of the group. There will be individual marks. The individual marks are going to be based on the answers of the students for the last questions I'm going to ask, and I can understand things. So it's not a hard thing to understand if someone is working or not. So as a group, you can vote for 1 leader. This leader is someone who is not going to do the whole thing, but someone who's going to create, for example, if we want to vote when to meet or how to meet, someone to contact, someone. So you can have 1 leader, which is a good option. And this leader is going to take the responsibility of the whole thing, okay? Not like dividing tasks, like you report, he's the one mainly contacting, not everyone is contacting. You understand things? So because you don't have 1 leader, you cannot even communicate. So one leader is the one who is going to put you on the same table, okay? Next, what you are going to do, you are going to explore the project together. I'm going now to discuss first the first project, which is first and second, okay, the machine learning projects. So in machine learning, we have a very famous data set, which is MNIST. MNIST data set is a digit data set, which is having a total of 70K like samples, which is not a little data set. We use it even for deep learning, which uses more data and all. We can use it still in the context of machine learning. And for this data set, the good thing that images in this data set are not having that huge size. It's only 28 by 28 size. And it's having like 10 classes, like numbers from 0 to 9, okay? We are going to perform classification at the end. So mainly the k-means, I'm presenting the notebook for this. You're going to present notebooks for the rest of algorithms, which are going to be classification algorithms, because classification task is different from clustering task. Clustering is to create groups of things. Classification, if I'm giving you something, you are going to assign to a given class, which is you are deducting the label, concluding the label for each particular element, okay? So this is a general case. So even if you are going to Google it, I'm sure you will find MNIST classification with the KNN, MNIST classification with the SVM, this is something which is going to be there for you. Now, I need, if you are going to put this in your CV, no one will take care. But if you only change the data set, people will give you importance and you're doing nothing. So what you will do is that you can apply this in particular like case in like dermatology, for example, for skin cancer. So you can classify skin lesions into malignant or benign. And this is going to be really proven, which is maybe the best machine learning for this particular task, okay? So this is a use case. You can also use it in a different context, like in biomedical. There is a different data set I'm providing here. And there in this data set, there are 2 versions. I'm going to keep you explore this. So minimum, I'm giving you this general one and 2 different contexts. One dermatology and one is the biomedical context. If you want, and you're going to be 7, so you can. If you want to use this is mandatory. But if you want to expand your work and as extension, you can have comparison with other data sets which can provide you more context, you can do that. Like the, I don't know, for example, the signs while driving or whatever your context, only if you have data, you are most welcome to present any solutions that are in this context, and that will be guaranteeing for you extra points like always. Okay, so to do this, I'm going to provide you with a data set. Okay, in general, this one I'm choosing because there is no problems. If, for example, we deal with a skin cancer case or medical context, always there is a problem with data that is not clean, it's not labeled, it's not balanced, and you will be suffering. So here, this data set is coming from a paper where they are doing the whole thing, segmentation. I'm making the work easy. You're going to have a separate like module of machine learning. You are going to deal for a whole semester probably with data cleaning and visualization and the whole thing. I would keep to other professors. For me, I'm supposed that this is done and we will focus a little bit on algorithms, okay? So the next step now, if you have your data, you cannot feed, for example, this one of the like size could be huge in this case, could be like 500 something, 200 something pixels. So you cannot feed your model a huge input. What you do in this case for machine learning algorithms, the first stage is, okay, given and supposing that the data we have is great. So the best condition, we have data. When I say data here, it's a huge problem, but it's solved. Next, before feeding to machine learning algorithm, we need to do feature extraction. Feature extraction, which is the job of an engineer, okay? It's a human who does the work. So for feature extraction, which means if you are having an image with a huge size, even the 28 by 28 in this one. You are going to extract the most important features. Instead of having this 28 by 28, you are going to move to some size, for example, which is, I don't know, 3 by 3, for example. The main and most important features, okay? And from the feature extraction step, you are now going to feed your ML algorithm, which is going to be one of these. I'm going to decide for both groups 1 and 2. The ML algorithm now must be evaluated. So you need to do the evaluation. And this will be doing through the semester, which metrics to use, like performance, like for example, performance, you have the accuracy, you have the error, you have the F1 score, you have many metrics, okay? So here I'm giving you this, I'm solving this step for you. Maybe if you come back, the whole thing is done, you come back to add more data, more context, why not? But in the start, you may focus with the feature extraction. Feature extraction itself is a whole research problem again. So if you ever try to look for what features usually people extract, you will find a long list. Okay? From this long list, I'm not going to let you explore the whole thing. At least one good way to extract features, and you understand that really well. If you're standing in an interview, I did the extraction of features, show you using this, for example, descriptor or extractor, and this is what I did. That you would be really performing well. If you try to understand the whole thing, then you end up understanding nothing. So here I am fixing one performant and robust feature extractor, which is called the scale and variant features transfer, which is the SIFT. So this is very simple and very easy to apply. I will let you one of the steps, because as you can see in the syllabus, we are going to have different validations. Okay, validations are, I will keep you working. Now I'm announcing the projects. I may give you one day. You will be you start working. And once you start working, after 1-2 weeks, I'm going to create an announcement. There will be first a validation. Everyone must be there, at least. So we try to have asynchronous students working with synchronous, but so even if asynchronous ones are not there, they present the whole thing, okay? Because I cannot engage them, I understand they may have different working time and so on. Next, now you have your classification algorithm. So you are going to choose, if you are a group of 7, then you are going to choose 7 algorithms from this list. You have the SVM, we are going to see this later. You have the KNN, you have the random forest, you have the decision tree, you have XGBoost, you have naive Bayes, you have the convolutional neural networks. So you can choose, don't think hard for 7 people. If each of you is going to only one algorithm, the things are not hard at all, okay? Then you focus on presenting things, okay? So this is for the first 2 projects. So they are going to have different choice of algorithms between both projects. Projects also can collaborate. For me, if you are learning, having troubles, you are asking each other, there is no problem. And this is why I said there must be leaders for the project, because it's better to communicate one-to-one to facilitate things. And next, so what we have, the other project, I'm not going to, the last project is going to be the implementation of a research paper. First step, so for this, there are mainly 3 steps, which is feature extraction, machine learning algorithm, and the evaluation. For the other project, there will be the first step, paper understanding, means the first validation. I am going to expect from you are presenting me the paper I'm giving you. To check if you are reading it well, understanding it well. I encourage those who have an interest in research to go for this project. If you do not have interest in research, I can understand that. These are engineering projects which are really good, okay? So, paper presentation, you are going just to present this paper for me. Next, after presenting this paper, and we are validating this step, there is an attempt to code this paper, present a code for this paper. So there will be a coding phase. The coding phase is, by the way, if you can see, I am one of the authors, so I already have the code for this paper. But I want just to check if you are getting it well, if you are coding it well. So after the coding phase, there will be an innovation phase. So we are going to discuss an implementation of new ways or new possibilities and so on. So this is for the 3 validation for this project. This is for the 3 validation for this project. So each project is going to have 3 validation and 1 final validation. Final validation for me, it's like you are done with the last class of AI. Everyone will be, in general, I can show you next time some pictures from what my students do in validation. So it's always like a party, like everyone is selling a product. We are done, we are presenting things. And there is a comparison, for example, which is the best machine learning in this context, what you can conclude from different data, and try to make it larger. If you can use papers, if you can use resources, you are free to use whatever you want. And if you are done with the work, you are also free to extend it to whatever field you want. If you have any questions, discussion we encourage this. So these are 3 projects. I expect you just try to join one of these groups, okay, as soon as possible, and start working as soon as possible. So I can share this draft just after today's class, and you must start working on this as soon as possible, okay? Any questions? Okay, so are you satisfied about the number of students per project, which is 7, 7, and 6? I think it's better to communicate with more students, so even if something is happening, we have more students. This is what I guess. And for this particular ML projects, the truth is that we have 14 students working on it. So even if you are stuck, this may encourage the communication between students, and this was my main objective. Okay, so I wish that everything is okay, and if not, we don't have time now, so try to send me emails. Okay, online.
Yep, that all makes sense to me.
Okay, that's great then. That is it. Okay, see you.